All right, so we're going to start off by reviewing what we went over yesterday. Please no talking. Take out your unit circle from yesterday. If you were gone yesterday, you can come up to my desk and grab a new one. If you were gone, in fact, I'll put them right over here. If you were here yesterday, you're just going to use the exact same unit circle, and we're going to add to it. What I want us to do here is at this point, we are still thinking of these ordered pairs. These ordered pairs as X, Y. We're going to change those into trig terms starting on Monday. So when we think about this first quadrant here, everything in the first quadrant has an X value that is positive and a Y value that is positive. Please write that down on your unit circle. This is quadrant 2. Where my hand is over, this is quadrant 2. In quadrant 2, the X values are negative and the Y values are positive. In quadrant 3, both the X and the Y are negative values. And in quadrant 4, the X's are positive and the Y values are negative. Now we talked about this a couple days ago. Another way to remember this when we apply it to trig terms is going to be all-star trig class. So please write that at the top, all-star trig class. As we transition into thinking these as X and Y values, and instead it's cosine and sine, we're going to come back to that all-star trig class and use the acronym for ASTC in order to tell us in which position can I find positive and negative trig values. All right, let's get started with what we did. Now, I shared with you yesterday that we spend a lot of time on ACT prep, and for that reason, we're going to do a little bit less time on trigonometry. So normally I would start by introducing 30, 60, 90 triangles and 45, 45, 90 triangles, and we would develop kind of a proof to how we are able to achieve these values for sine and cosine. Because we're limited on time, I'm going to teach you a trick. And the trick we learned yesterday is to make this capital U. And as we make the U in the first quadrant, these are going to be our reference angles. So I'm going to write that down. These are our reference angles. And as I make this U, I'm going to count 1, 2, 3, 1, 2, 3 in the numerator. Here we go. 1, 2, 3, 1, 2, 3. Twos will always go on the bottom of every fraction, and then I'm going to take the square root of the numerator in all 6 values. Now, if I'm able to evaluate that square root and get a nice integer value, then I'll do so. So do we know what the square root of 1 is?
1.
It's 1, so I don't have to put it. Do we know the square root of 3? Nope, because it's ugly. It's irrational. Also, the square root of 2 is ugly, and the square root of 3 is ugly. That's why we don't put a square root on the 1, because I know the square root of 1 is 1. So yesterday we spent time, and we may have not used the words reference angles. I may have called them something else. But I wanted you to understand that this is the same as these. So on your paper, can you please put your fingers in these 2 positions? These 3 positions. These have all equivalent values. The only difference is we change the signs. So these and these are all reference angles. Okay, this is the reference angle, for these 3 other positions. Now put your finger up here at radical 2 over 2, radical 2 over 2. This is the reference angle for these 3 other positions. And lastly, way up here at 1/2 and radical 3 over 2, this is the reference angle for these 3 other positions. And then we went ahead and we identified that if you want to think of this as a compass, so this would be the east, this is 1, 0, because it's a unit circle, 1 unit circle. I go out 1 and I don't go up or down. I go 1 to the left and I don't go up or down. I don't go left or right and I go up and down. And I go up 1, I don't go left or right, and I go down 1. And so we were able to create this. This is what we created yesterday. Now what we're going to do is we're going to add to that. We're going to add to that. So how are we adding to that? So we've now been able to name these points. What does that really mean? This means to get to this point on the unit circle, I go a distance of radical 3 over 2 to the right, and then I go up 1/2. How do I get to this point? I go to the right 1/2 and I go up radical 3 over 2. How do I get to this point? I go to the left a distance of radical 2 over 2 and up radical 2 over 2. Can I have a thumbs up or thumbs down if that makes any sense to you? It's okay to be a thumbs down. Okay, next. Now we're going to measure the interior angles here. We're going to measure the interior angles. And there's 2 ways to measure it. Students prefer, especially when they start working with trigonometry, they prefer to work with degrees. It makes more sense to them. They're used to working with degrees with triangles. We are most often going to work with radian measurements. So today we're going to introduce both. And I'm going to teach you the shortcuts. Okay, are you ready? I want us to forget right now about the pink. Does everybody see that? We're going to forget about the pink. Let me put this on pause really quick. When we look at this, we are going to go through and we are going to label these in two different ways. I'm going to start off right now with the 30-degree measurement. So I want to see how many are there. So I made my little triangles here, and they're actually called sectors. Why are they called sectors? Because a triangle would have look different than a sector. A sector is like a piece of a pie or a piece of pizza, and so it has a curved end. So when I look on top, if I do just the top half, that's enough for us to figure out the rest of these. But if I do the top half, we can see how many sectors. These are all equal sectors. That means this angle inside, if I did this correctly, would all be the same. How many sectors do we have on top? 6. So how many are we going to have on the bottom that are this exact same size? 6. Okay, good. Now you should know this from geometry. You may not remember it. What is the degrees of an entire circle? 360. So let me move these to the side. Let's come over here. We start at 0 degrees, and when we finish, we're at 360. Okay, so if I grab a calculator real quick, and I take 360, now we know there was 6 equal sectors on top, and there were 6 equal sectors on the bottom, so that's a total of 12. If I take 360, that's one entire circle, so one revolution, and I divide it by 12, I get 30-degree increments. Again, why is that? Because we had 6 sectors on top, and there would be 6 sectors on the bottom that same size. So if I take and I divide 360 by 12, each one of those would be 30. So here's my shortcut to doing this. You ready? Come up here. So in this position, I'm going to start by just putting a 3. Now give yourself some space. Now in this position, I'm going to skip this one and I come up here. Okay, I come up here. Now this one right here would be a 6. Give yourself space. I'm going to cover those up. And this one, it would be a 9. Space. Here's a 12. Give yourself space. Skip this one and come down here because that's the next one. This would be 15. And what I'm doing is I'm counting by 3s. So if I come up here, I start at 0, and then when I move up, it's 3. I skip this one because notice that it's not a full. So 3, 6, 9, 12, 15, 18, 21. I skip this because it's not a full. 24, 27, 30. Skip it, it's not a full. 33, and back to 360. And then I go through and I add a 0. 30, 60, 90, 120, 150, 180, 110, 240, 270, 300, and 330. Now, what do we do with the parts that we skipped? Well, if I come back to this position, notice that the distance between 30 to 60 is a distance of 30. And this is directly in the middle of it. So half of 30 is 15. So from the bottom, I'm going to say, what is 15 plus 30? It would be 45. So I'm going to go to the smaller of the two values, and I'm going to add 15. Here we're missing one that's directly in between. The smaller of the two values is 120. If I add 15, I'm up to 135. The smaller of the two values is 210. If I add 15, I'm up to 225. The smaller of the two values is 300. If I add 15, I'm up to 315. We've taken care of doing all of the degree measurements. Now we're going to move on to radian measurements. Again, just like we can measure temperature in a room in terms of Fahrenheit or Celsius, we can measure distance on a highway in terms of miles or kilometers. We are able to measure interior angles in terms of degrees or radian measurements. Okay, now here's radians. I'm going to come back up here and we're going to teach you the shortcut. So everybody look up here. I'm going to ask you to put down your pencil or pen and just pay attention to this first one. How many equal sectors do I have on top? 6. Does everybody see that? There's 6 here? Okay, so I'm going to go through and I'm going to do this. Okay, 1 pi over 6 because it's the first one. Okay, gotcha. Now when I do this one, guess what this is going to be? 2 pi over 6. But hold on here. 2 pi over 6 is not wrong. 2 pi over 6 is right. But can we reduce 2 pi over 6? We can. And if you're not great at reducing your head, you can hit the green key and directly to the right. I can go 2 over 6. Oops, so sorry. 2 over 6 and reduces to 1/3. So in this position, I'm going to write 1 pi over 3. But 2 pi over 6 is not wrong. If you tell me 2 pi over 6, I count that as right. It's just not reduced. Okay, got it? I'm going to come up to the next one. Okay, now I'm up here. So I'm on my third sector. So guess what I put into this position? 3 pi over 6. So yes, in this position, 3 pi over 6 is right. But what can 3 pi over 6 be reduced to? 1/2 pi, or 1 pi over 2. In this position right here, we're on our fourth equal sector. So yes, 4 pi over 6 is not wrong, but what does 4 pi over 6 reduce to? 2/3 pi, or 2 pi over 3. Nice job. I go to my fifth sector, which is right here, and in this position I'm going to write 5 pi over 6. 5 pi over 6 in this position, 5 pi over 6. And lastly, in the top half, this would be our sixth one, so 6 pi over 6. So in this position, yes, 6 pi over 6 is correct, but that reduces to simply 1 pi. And we're going to keep counting down below. So I've done 6 out of 6. This becomes 7 pi out of 6. I skipped this one because it's not a full one. If you're confused and you're a visual learner like myself, notice this is not a full one. That pink would be cutting it in half. Okay, so I've done, in this position was 7 out of 6. Now this would be 8 out of 6. 8 out of 6 is not wrong. I would not count that wrong. But you may not see 8 pi over 6 on a test. What would that be reduced down to, knowing that 8 and 6 are both even numbers? Yep, 4 pi over 3. My next one would be 9 pi over 6. So in this position, it would be 9 pi over 6. 9 and 6 are both divisible by 3, which gives me 3 pi over 2. All right, in this next one right here, we did 9 over 6. This would be 10 over 6. So in this position right here, I would have 10 pi over 6. But what is 10 pi over 6 reduced to? They're both even, so it's 5 pi over 3. 5 pi over 3. Okay, moving up to the next one. So it was 10 over 6. This is going to be 11 over 6, 11 pi over 6, and this is 12 pi over 6. Well, 12 pi over 6 is the same as 2 pi, or 12 pi over 6. That's how I was able to achieve 1 revolution working with radians. Now, there's a specific type of radians. The reference angle is pi over 6, and then we would just go 1 out of 6, 2 over 6, 3, 6, 4, 6, 5, 6, 6 out of 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6, and 12, 6. But which ones have I not named yet? Turn to your partner. Which ones have I not identified? What color up here have I not identified for radians? What color have I not identified for the radians? Would you agree that it's this purplish pink color? Yes? Okay, so my question is, on the top half, how many of these sectors would make up the top half? It would be 4 equal sectors on top, correct? That's how I determine the denominator. So over here is going to be 1 pi over 4. Now this would be 2 pi over 4, but guess what 2 pi over 4 reduces to? 1/2. This is going to be 3 pi over 4. This would be 4 over 4. Well, 4 over 4 is the same as 1 pi. This is 5 pi over 4 down below. This is 6 pi over 4. Well, 6 pi over 4 reduces to 3/2. This is 7 pi over 4.